When COVID-19, a disease caused by SARS-CoV-2, evolved, scientists thought that this virus was linked to SARS-CoV, a virus responsible for the outbreak of a disease called severe acute respiratory syndrome in 2003. This is because both the viruses come from the same family, the coronavirus. Both of them are transmitted via respiratory droplets, and both of them lead to respiratory issues. So, they compared the genetic information of both these viruses to find out that they're 80% similar, but the 20% made a huge difference. It's like comparing lemon with lime. Normally, when a coronavirus enters your body, it would use its crown-like spike protein to enter the cell it wants to live in, the host cell. This happens so as the spike protein has a specific shape to bind to a specific site on the surface of the cell, like a lock and key. If we look at it that way, we call this specific site a receptor and the region that fits the receptor binding domain. Note that the receptor and receptor binding domain are specifically shaped. One key won't fit all locks, so the coronavirus can only enter the cell that has a specific receptor it can fit into. While entering the cell, the virus now uncoats the proteins that surround its genetic material called the RNA and releases it into the cell. The RNA instructs the cell to make more copies of it and then takes over the genetic information in the cell and soon controls the genetic machinery of the entire cell, programming it to make more of the viruses. These viruses are released out of the cell to infect other cells and the cycle continues. Both SARS-CoV and SARS-CoV-2 have a common receptor to bind to, so they attack similar organ cells with the same receptor, mainly the lungs. So what could possibly make the virus behind COVID-19 so different? Well, it's a spike protein. The host cell secretes an enzyme called furin that acts like a scissor. The amino acid, which are the building blocks of protein, on the spike protein of the SARS-CoV-2 has a specific sequence that furin cuts, called the furin cleavage site. In doing so, furin makes the spike protein biologically active, which facilitates the entry of the coronavirus into the host cell, as it makes it much more easier for the virus to attach to the cell receptor, unlike any other types of coronaviruses. Let's say my phone password is a sequence of amino acid in a spike protein. Only a particular password will help me unlock my phone, the same way furin will cut a particular sequence of amino acid on the spike protein, making it easier for the coronavirus to enter the cell. If the spike protein doesn't have the sequence of furin cuts, that is, if I forgot my password, I won't be able to unlock my phone easily, the same way a coronavirus may not enter the cell easily. This is the first time furin activity has helped a coronavirus enter the cell thanks to the unique combination of amino acid on the spike protein. The presence of furin in cells of various organs suggests that SARS-CoV-2 can infect multiple organs at once. Scientists believe that the spike protein of SARS-CoV-2 binds 10 times more strongly to the receptor as compared to the spike protein of SARS-CoV. These characteristics make SARS-CoV-2 one of the most infectious coronaviruses. This is why we need your help to follow all the precautionary methods listed by the World Health Organization until a cure or vaccine is found. Stay home and stay safe.